Massachusetts Institute of Technology, Mathematics for Computer Science, Tom Leyton. Lecture the first, Introduction and Proofs.
The following content
is provided under a Creative
Commons
license.
Your support
will help MIT
OpenCourseWare
continue to offer high-quality educational resources for free.
To make a donation
or view additional materials
view additional materials from
hundreds of MIT courses, visit MIT OpenCourseWare.
MIT courses. Visit MIT OpenCourseWare at ocw.mit.edu.
Who can tell me what a
Professor, who can tell me what a proof is?
proof is? Any ideas?
Any ideas of what is a proof anyway?
What is a proof anyway? Any thoughts? Yeah.
Yeah? Audience. It's a chain of statements, each logically supported by the previous ones that get you from a set of assumptions to a set of conclusions.
Very good.
Professor, very good.
I like that.
I like that.
That's very close to...
That's very close to what we're gonna do here. Yeah?
What we're going to do here. Yeah. Now that's a...
No, that's a special kind of proof. Though...
Special kind of proof, though. That's a
That's a mathematical proof.
mathematical proof. And I'm going to write...
And I'm gonna write a definition write
a definition very close to that
in a few minutes.
in a few minutes. But
proofs exist beyond mathematics.
proofs exist beyond mathematics. Can anybody
think of a higher level?
think of a higher level notion of what a
proof is?
proof is? That's correct.
That's correct. What you said, but there's
Correct what you said, but there's a higher
meta level notion of what a proof is beyond that.
meta level notion of what a proof is. Beyond that. It may have no
logical deductions, potentially.
Logical deductions, potentially. May have no assumptions.
It may have no assumptions.
Any thoughts?
Any thoughts about a proof?
About a proof? Okay, well,
I think generally a proof
is considered
across multiple fields.
Across multiple fields as a method
for ascertaining the truth
for ascertaining the truth. And you described
one method.
one method. Now,
by ascertaining, I mean establishing truth, verifying.
Ascertaining, I mean establishing truth, verifying truth.
Truth.
And there's lots of ways.
And there's lots of ways to ascertain truth.
Ways to ascertain truth in society.
In society and even within science.
And even within science. What are some examples?
What are some examples of ways that we ascertain truth in society?
Truth in society. Yeah?
Yeah. Audience observations, like seeing that piece of chalk.
Like seeing that piece of chalk will
fall to the ground.
Observation.
Professor, observation, experiment.
Experiment and observation.
And observation. Excellent.
Excellent.
And that's the bedrock of physics.
It's the bedrock of physics. Who really
knows if there's gravity out there?
Knows if there's gravity out there. Well, we observe
it. And so we then conclude that the truth.
Then conclude that's the truth. There's gravity.
There's gravity. And we have laws about it.
We have laws about it. That's one good way.
That's one good way.
Okay, what's another way?
What's another way of ascertaining truth?
Of ascertaining truth. Across
scientific disciplines or beyond science, just
scientific disciplines or in science, beyond science, just in society.
In society?
How is truth established?
How is truth established?
What are the ways? Yeah.
Yeah? Audience. Well, establishing what's false.
What's false?
You can know what things aren't true.
So, what things aren't true, then that helps.
Then that helps you narrow down what is true.
Narrow down what is true.
Yes.
Professor, yes. Truth, yeah, that's great.
Truth, yeah, that's great. Truth is the opposite.
Truth is the opposite of falsehood.
Opposite of falsehood. How do we establish?
How do we establish falsehood?
Falsehood. What are the ways of
What are the ways in doing that?
doing that? How do you decide something?
How you decide something is not true in everyday, yeah?
Something is not true in everyday life. Yeah.
Audience, find counterexamples.
Find counterexamples.
Professor, find counterexamples. Yeah, that's good.
Yeah, that's good. So,
in fact, even a step more general, sampling.
in fact, even a step more general, sampling. Counterexamples.
Counterexamples are ways.
are ways. You know, if you do something,
If you do something, an experiment, 10 times,
an experiment 10 times, and every time it comes out one way, huh?
and every time it comes out one way, that's truth, maybe.
That's truth, maybe. But there's fields of that.
But there's fields where that becomes truth.
Becomes truth. What about other ways?
What about other ways?
How are we going to decide?
How are we gonna decide if Roger Clemens is
If Roger Clemens is guilty of perjury?
guilty of perjury for lying about steroids to Congress?
For lying about steroids to Congress.
Steroids.
He did it or he didn't.
He did it or he didn't.
And how are we going to decide
How are we gonna decide that?
that? What's the truth behind it? How is that truth
How is that truth gonna be ascertained?
going to be ascertained? Yeah?
Yeah? Audience, would it be by examining the evidence? Professor, examining evidence.
Examining evidence, and who makes
And who makes the conclusion there?
the conclusion there?
Audience, juries.
The jury.
The jury,
Truth is established.
truth is established by juries or judges.
Established by juries or judges. You know,
You know, Blago I can never pronounce
I can never pronounce his name there.
his name. The Illinois governor, Blagojevich, he's guilty.
The Illinois governor, Blagojevich, he's guilty. That's the truth.
That's the truth of, not of conspiracy.
Okay, not of conspiracy, trying to sell Obama.
Trying to sell Obama a Senate seat,
A Senate seat, but of lying to
but of lying to the authorities about campaign financing.
the authorities about campaign financing. OJ
OJ is guilty not of killing his wife,
is guilty, not of killing his wife, but
but of breaking into an apartment to steal back
of breaking into an apartment to steal back some of his merchandise.
some of his merchandise.
Okay, so judges and
So judges and juries make decisions on truth.
juries make decisions on truth. What are other
What are other truth? Bigger truth even than judges
truths, bigger truths even than judges and juries
and juries in society.
in society? There's one really
There's one really big one that causes a lot of issues.
big one that causes a lot of issues, yeah?
Yeah? Audience. Religion.
What is it?
Religion. What is it?
Religion, the Word of God.
Professor, religion, the Word of God, broadly construed here.
God. Broadly construed here. or religion.
For religion.
You know? Now that one's really
Now, that one is really hard to argue about
hard to argue about. You know, because you
because you believe it.
believe it. You know, and it's
And especially if you are not talking to God regularly
especially if you're not talking to God regularly and somebody
is, well, it's hard to argue about the truth.
is, well, it's hard to argue about, you know, the truth. So you rely
So you rely on others to interpret it for you.
on others to interpret it for you often.
Often, a priest or a minister, a rabbi,
You know, a priest or a minister or a rabbi. Okay, and
it gets complicated because you can end up
complicated because you can end up with conflicting
with a conflicting truth based on who you think you are talking to,
truths based on, you know, who you think you're talking to or who you're representing.
or who the translator is for you.
The translator is for you. You know, another one is the
word of your boss.
word of your boss. Whatever the boss
Whatever the boss says is right.
says is right. Often in business,
Often is business, the customer is always right.
the customer is always right. That's the truth.
That's the truth. Whatever the customer says.
The customer says. All right? You know, with Donald
Trump as your boss, you'd better agree.
Trump is your boss, you better agree or you're fired.
Or you're fired.
Right? You know? Often in class,
Often in classes, the professor says it. It is true.
as the professor says it, it is true. Because the
Because of the authority said it.
authority said it. That's not true here.
That's not true here.
All right, that will not hold.
That will not hold.
And one of the nicest
And one of the nicest things about math that I like a lot
thing about math that I like a lot is that the
youngest student can stand up
youngest student can stand up against the
most oldest, most experienced professor
oldest, most experienced professor and win
an argument on mathematics.
an argument on mathematics. In fact, I do get
pleasure when a student comes up and proves me wrong.
pleasure when a student comes up and proves me wrong. I loved it
when that student came in.
when that student came in and she showed
me what I said
what I said really wasn't right.
Wasn't right when you looked at it carefully.
When you looked at it carefully or in a different light.
Or in a different light.
You know, now,
sometimes if I do it on the board here and it's in class.
Sometimes if I do it on the board here and it's in class, well,
that's fun.
No, that's fun. I feel a
little embarrassed afterwards.
But it's a good thing
But it's a good thing about mathematics.
Mathematics is that
you can have that kind of dialogue.
Okay.
Okay, another one which is related to the Word of God.
Another one, which is related to the Word of God
sometimes, is inner conviction, very popular.
is inner conviction. Very popular in computer science.
In computer science, believe it or not, with the mantra.
Believe it or not, with the mantra, there are
no bugs in my program.
no bugs in my program. Can't tell you how many
I can't tell you how many times you hear that.
times, you hear that. Closely
Related is I don't see why not something is true.
related is I don't see why not something is true. Now that's a good
And that's a good one because that transfers the burden of proof to anybody who disagrees with you.
there's the burden of proof to anybody who disagrees with you. You don't have to
You don't have to prove.
prove. You say, I don't see why.
You just say, I don't see why it's not true.
It's not true. All of a sudden,
the other person who's questioning you,
the other person who's questioning you becomes their job.
it becomes their job to disprove you, which is not so good.
To disprove you, which is not so good. Okay, now in math.
Okay, now in mathematics, there's this higher level.
Mathematics, there's this higher level, and
someone stated it very clearly up there.
stated it very clearly up there. Let me write it up
Let me write it up here.
here. In
mathematics, we have a mathematical proof.
we have a mathematical proof. Is
a verification of a proposition.
Verification of a proposition by
a chain of logical deductions from a set of axioms.
of logical deductions from a set of axioms. Now, that's a bit
of mouthful.
of a mouthful. There's three
important components here.
Important components here. Propositions,
logical deductions, and axioms.
Logical deductions, and axioms. And
we're gonna spend the rest of the class today talking about each of these.
And then give an example.
And then give an example of a proof.
We'll start with
propositions. A proposition is a statement that is either true or false.
Is a statement that is either true or false. You may not know
which one, but it's one or the other.
which one, but it's one or the other.
A simple example, 2 plus 3 equals 5.
Example, 2 plus 3 equals 5. Now that's a true
proposition.
True proposition.
Here's one that's a little more interesting.
One that's a little more interesting.
For all n in the set of natural numbers,
n in the set of natural numbers, n squared plus n plus 41 is a prime number. Plus n plus 41 is a prime number. All right, now
I know I've used some notation here.
This
is the upside down. A is the for all symbol.
The upside down A is the for all symbol. How many people
have not seen that symbol before?
Not seen that symbol before? I had a bunch of you.
A bunch of you.
You're going to see a bunch of symbols.
You're gonna see a bunch of symbols here first week.
Symbols here, first week. And that means
for every possible choice of n.
For every possible choice of n, and this is in
the natural numbers, which is the set 0, 1.
In the natural numbers, which is the set 0, 1,
2, 3, and so forth.
2, 3, and so forth. It's the natural.
It's the natural numbers.
It's
basically the integers, but not negative.
Integers, but not negative. So we are saying for every natural number, it asked for 0. For every natural number, i.e. for 0, for 1, for 2.
For 1, for 2, and for 3, and so forth. This expression.
3 and so forth. This expression is a prime. Now a prime
number is a number that is not divisible by any other number besides itself and 1.
Divisible
by any other number besides itself and 1.
By any other number besides itself and 1. So 2, 3.
So 1, 3, 5, 7 are prime.
3, 5, 7 are prime. 9 is not.
9 is not because it's 3 times 3.
Because it's 3 times 3. Now this part
here is called the predicate.
Here is called the predicate.
And a predicate is a proposition whose truth
is a proposition whose truth
depends on the value of a variable, in this case n.
on the value of a variable. In this case, n. All right, this
is referred to as the universe of discourse.
is referred to as the universe of discourse.
Discourse.
It's the space of all.
It's the space of all the things we're talking about.
All things we're talking about. We're only talking
about natural numbers here.
about natural numbers here. This is called a
Quantifier.
quantifier. We'll see more
We'll see more quantifiers later.
quantifiers later. All right, now to see
Alright, now to see if this proposition is true.
if this proposition is true, we need to make
sure that this predicate is
sure that this predicate is true for
every natural number n.
every natural number n. So let's see if
we can check that.
we can check that. Let's try some
values.
So we'll try
n is 1, 2, 3, and so forth.
n is 1, 2, 3, and so forth. And we'll compute n squared plus n plus 41. n squared plus n plus 41. And then we'll check
is it prime?
Is it prime? So for n
equals 0, n squared plus n plus 41 is 41.
Equals 0, n squared plus n plus 41 is 41. Is 41
is 41 prime?
Prime? Yeah.
Yeah. Nothing divides 41 but itself and 1.
Nothing divides 41 but itself and 1. All right, let's try 1.
All right, let's try 1.
1 squared plus 1.
1 squared plus 1 plus 41 is 43.
Plus 41 is 43. 43
is 43 prime?
Prime. Yes.
Yes.
Let's try 2.
Let's try 2.
2.
We get 4 plus 2 is 6 plus 41 is 47.
4 plus 2 is 6 plus 41 is 47.
Is 47 prime?
7 prime.
Audience, yes.
Yes.
Professor, yes.
Looking good. 3. I got
3 got 9, 12, 53.
9, 12, 53. 53 prime?
Is 53 prime?
Yeah.
Yeah.
And
I could keep on going here.
Keep on going here. I could go down to
I could go down to 20.
20. I get
4 and 20, 4 and 61.
420, 461.
In fact, that is a prime.
It's a prime. And I could just keep
on going here.
Keep on going here. Go down to 39.
Go down to 39.
9,
I get 16 and 1.
1601.
1601.
Check that as a prime.
That is a prime.
The first 40
The first 40 values of n, the proposition is true.
values of n, the proposition is true. The predicate is true.
The predicate is true.
It is prime.
It is prime.
Now,
this is a great example because in a lot of fields,
this is a great example because in a lot of fields, physics,
for example, statistics, often
for example, statistics often, if it's true, you checked 40
examples.
That's above and
That's above and beyond the call of duty.
beyond the call of duty. It's always true.
It's always true.
So yeah, this
this must be true, right?
must be true, right? No.
No, wrong.
Wrong. Often you'll see
this in a lot of scientific fields.
this in a lot of scientific fields. It is not true.
It is not true.
Can anybody give me
an example of n
an example of n
for which n squared plus n plus 41 is not prime?
n squared plus n plus 41 is not prime? Yeah.
Yeah. Audience, 40.
40.
40. Good.
Good. Let's see about
40.
40. 40.
40 squared plus 40 plus 41 is 1681.
Squared plus 40 plus 41 is 1681. What's that equal?
What's that equal?
41 squared.
41 squared.
Squared. So it is not prime.
So it is not prime.
Prime. Somebody give me
an obvious example where it's not prime.
obvious example where it's not prime.
Audience, 41.
41.
Professor, 41. Yeah, 41 squared.
Yeah, 41 squared. Yeah.
We get everything is divided by 41.
Everything is divided by 41. But
40 is the first break point.
the first break point.
So the first 40 examples work, and then it failed.
First 40 examples work, and then it fails. So this
proposition is false, even though it
proposition is false. Even though it was
looking pretty good.
pretty good. There's a reason
I'm doing this.
I'm doing this. In fact, I'm going to do it some.
In fact, I'm gonna do it some more here.
More here. I'm going to beat you.
I'm gonna beat you over the head with it.
Over the head with it.
Here's a famous in mathematics statement.
Famous in mathematics statement. A to the 4th.
To the 4th plus b to the 4th plus c to the 4th
plus b to the 4th plus c to the 4th equals d to the
equals d to the 4th has no positive integer solutions.
4th has no positive integer solutions. That is a
That is a proposition.
proposition. Now, this
proposition was conjectured to be true by Euler.
proposition was conjectured to be true by Euler in
1769.
Euler's
Euler's a big honcho in math.
honcho in math. You know, we still talk about
him a lot, even though he's
him a lot, even though he's been dead for
centuries.
It was
unsolved for over 2 centuries.
unsolved for over 2 centuries.
Mathematicians worked on it.
It was finally
disapproved by a very clever fellow.
disproved by a very clever fellow named
Noam Elkis. 218 years later, after it was conjectured,
218 years later, after it was conjectured, he works at that
he worked at that other school down the street.
other school down the street, and
he came up with this. A equals 95,800.
Equals 95,800. B
equals 217,519.
Equals 217,519. C equals 4.
C equals 414,506.
414,560. You don't have to remember.
You don't have to remember these numbers. We're not gonna quiz you on that. 422, 481.
Quiz you on that. 422,481. Now he claims.
Now he claims. I've never personally checked it.
I've never personally checked it, but presumably people have.
But presumably people have. You plug those in here.
You plug those in here, and you have an equality.
And you have an equality.
So he says.
So he says.
So in fact,
the correct proposition.
True proposition is
there does exist A, B, C, D in the positive natural.
There do exist A, B, C, D in the positive natural numbers.
Numbers such that the fourth plus B to the fourth plus
such that A to the fourth plus B to the fourth plus C to the fourth.
C to the fourth equals D to the fourth.
Equals D to the fourth. All right, I used a new quantifier here called there exists. Quantifier here called there exists. Instead of an upside down.
Instead of an upside down A, it's
Down A, it's a backwards E.
a backwards E. Don't ask me why.
Don't ask me why. That's what it is.
That's what it is.
The plus
The plus means you can't have zero or negative numbers.
means you can't have zero or negative numbers, so
So there are the positive natural numbers.
these are the positive natural numbers. And here's your predicate.
And here's your predicate, which of course the truth of this.
Which, of course, the truth of this depends on the
Depends on the values of A, B, C, and D.
values of A, B, C, and D. All right, took a long.
It took a long time for figure out that actually there
Long time to figure out that actually there was a
was a solution here.
solution here. Obviously, everything they tried
Obviously, everything they tried until that time failed.
that time failed. Let me give you another.
Let me give you another one.